I would like to show you that the law of conservation of energy is false. I will do this using an Atwood machine and a cylinder and spheres machine. The cylinder and spheres machine are available on the internet. There's several videos of them working, and they show that the momentum can be transferred back and forth from the small object to the large object. And the quantity of motion being transferred back and forth is momentum. Well, an Atwood machine produces very large quantities of momentum. If you have a 50-to-1 Atwood machine, that would be 1 kilogram accelerating 50 kilograms. This top mass is 1 kilogram more massive than the lower mass. So that gives you 9.81 newtons of force in the 1 kilogram. That is accelerating a total of 50 kilograms, itself and the other 49. So you divide the 9.81 newtons by the 50 kilograms, and you come up with 0.1962 meters per second acceleration. When you put that acceleration into the velocity formula for an object that has dropped 1 meter, and the 2 is part of the velocity formula, plus the acceleration rate, you will have a answer for your formula of 0.6264 meters per second velocity as the more massive weight reaches the 1 meter drop. So that is 50 kilograms moving 0.6264 meters per second. This is a Atwood machine that proves F equal ma. So there isn't too much question about it. You can check it on the internet, and you'll see thousands, well, hundreds at least, probably literally thousands, of these Atwood machines being experimented with. So the momentum of the system, the total system, is 50 times this velocity, which will give you 31.32 units of momentum. Now in free fall, which is all you need to restart this, because you've only dropped 1 kilogram 1 meter. And the opposite of free fall, of course, is if you have an object moving at 4.429 meters per second up, it will travel up 1 meter. Well, the formula for determining that is the same formula. You drop one object 1 meter. It has a standard acceleration rate of 9.81 meters per second, and that will give you a velocity of 4.429 meters per second after a drop of 1 meter. So to reload this system, you only need 4.429 units of momentum. It is only 1 kilogram, and it is moving 4.429 meters per second. Now the Atwood, as we demonstrated, produces 31.32 units of momentum, and we already have a 700%, little over 700% increase in the total momentum needed to reload the system. But it gets even better than this, because what we're really interested in is energy. So we take our momentum over to the cylinder and spheres machine and give the cylinder and spheres a momentum of 31.32 units. So when we place those 31.32 units of momentum into the cylinder and spheres machine, then we let the cylinder and spheres machine do its work, and it will throw the 1 kilograms. I used plural because you have 2 spheres that are a half kilogram each, and it throws them both off. The total mass is 1 kilogram. And those spheres will be moving 31.32 meters per second. So we plug it into the kinetic energy formula, which is 1/2 times the mass times the velocity squared, and we can produce 490.5 joules of energy. Now going back to free fall is only 4.429 meters per second for 1 kilogram, and that will give us 9.81 joules of energy. So to reload the system, we need 9.81 joules of energy, and we produce 490.5 joules by putting it in both of these machines, the Atwood machine and the cylinder and spheres machine. That gives us a 5,000% increase over the original energy, because we started with 9.81 joules of energy in, and we got out 490.5 joules. So the law of conservation of energy is false.